Alright, we're now going to find the exact unity point for this synchronous motor running with 6 Newton meters of load. Okay, so the way we do that, once we got this thing up and running, we're going to watch our line current to the motor and then slowly adjust our field current until our line current gets to the absolute lowest value. The video before, we know it's somewhere around an amp. But we're going to see if we can dial in and find out exactly what level of current it takes to keep this synchronous motor running at unity. It's an amp and a half. So at an amp and a quarter, 1.25 amps, we've got a line current of 4.6 amps. I'm going to slowly bring this down. I think we'll settle in around 4.4. Drop to 4. Oh. 4.5. Oh. So at 1.1 amps, 1.1 amps of field current, we're getting a line current of 4.5. And then if we take this down to 1 amp of field current, our line current comes back up to 4.7. So at an amp and a quarter, we're 4.6. At 1.1, we're down at 4.5. And then if we drop all the way to 1 amp, our current starts to come back up. So that means that in order for this motor to operate at unity, we need 1.1 amps of field current. Plot this on our graph. We'll go back to that graph before. Luckily it hit basically in the belly just the way I drew my arc. That was luck, pure luck, not good management for sure. So our exact unity point is 1.1 amp of field current. Okay, so at unity we had 4.5 amps of line current. We take that multiplied by 208 multiplied by root 3, and that is how many watts of load we're applying, or we need, in order to drive that 6 Newton meter load on the Prony brake. So when you're trying to determine the actual power factor, you find your unity level, unity point, calculate that up. That'll always be your watts, or your base of your power triangle if you're going to do it that way. And then from there you take your line current multiplied by 208 times root 3, and that'll give you your S, or your hypotenuse, and from there you can determine your power factor, right? So with 2.5 amps of current, you take your 2.5 amps current was drawing 12, so you would take 12 amps times 208 times root 3. That would give you your hypotenuse, and then you use Pythagorean theorem and determine how many capacitive bars we're putting back in there. The other way, of course, is to you can just use your line current, right? 4.5 is your resistive current. We know that 12 amps was our line current, and you can find your power factor on that ratio as well.